Welcome to another lecture of our machine learning playlist. Today we are going to learn about a machine learning model, that is perceptron model, and we are going to discuss an example which we are already discussing in my previous two videos, that is the banking credit system. I am going to make an model which will give us a hypothesis which is going to decide if the customer with the given details by a bank is good or bad. Name of the model is perceptron model. So let's start. So here x, I have already told you that x is the input, that is that customer details, or we can also say that it is the training data, training sample. Okay, so the attributes of the customer. So x is a set of vectors. Okay, so x1, x2, x3, these all are vectors with different parameters. What the perceptron model do, it gives different weights to our attributes. Okay, so the perceptron model gives different weights to our attributes. Suppose I have already told you that there are different factors deciding if a customer is good or bad, that is his profession, his age, his previous records, his bank balance, his salary. So these are all parameters. Which parameter should carry higher weight and which parameter should carry lower or even negative weight, that is decided by this perceptron model. So it at the initial stage it gives different weights to our attributes, and by correcting those weights it gives us a perfect formula, that is a linear formula which separates our data into two different parts. Okay, two different parts means good customer or bad customers. Okay, so suppose I am giving every attribute, that is x0, x1, x2, every attribute a weight, w0, w1, w2, right, like this. Okay, suppose there are d attributes, so I will be giving d weights. So from x1 to xd and w1 to wt. So I will be multiplying the parameters with the weights and adding them. Okay, so I will be doing summation I equals to 1 to d wi xi. Okay, so if the summation of all these weighted values is greater than a certain threshold value, then the credit is approved, that is I will be giving the customer a loan assuming that he is a good. But if the summation of the weighted values is less than the threshold value, then we will deny the loan. Okay, I will deny the credit. So the linear formula of the perceptron model can be written as h of x. What is the actual value of this h of x? How can we write that? I will be showing that you soon. So now let's check this part. Okay, so this is what we got, that is the summation is greater than threshold, it is approved, or if it is less than threshold, it is denied. Now let's take the threshold on the left hand side. So let's decrease the threshold value from the weighted sum, and if this of this total value is greater than 0, then it is approved, because this is coming from where? This is coming from this. So then if it is greater than 0, then it is approved. So we can write this as +1, or if this is less than 0, then it is denied. We can write that -1. That is the output. Okay, if it is approved, we will say +1. If denied, we will say -1. Let's write it like that. Okay, so now what is the value of this threshold? So we will be writing this threshold as -w0 x0. These are dummy variables. Okay, so these are dummy variables, and we will be writing the threshold in terms of like this, -w0 x0. So it will become what? It will become summation of I equals to 1 to d wi xi plus w0 x0, because minus of minus w0 x0 will become plus w0 x0. So this minus w0 x0 is the value of the threshold. Okay, so now we can write this as I equals to 1 to d wi xi plus w0 x0. This is the value, and we want what? We want that this total value should be greater than 0, then the credit will be approved, and if it is less than 0, then the credit is denied. So greater than 0 means what? Greater than 0 means it is a positive value, and less than 0 means it is a negative value. So to differentiate a value into positive and negative values, we use the sign function. Okay, so if we use the sign function into this whole value, if this is positive, then this sign function will give me +1, and if the value of the whole thing is negative, then the sign function will give us -1. Okay, so the sign function will always give us +1 or -1. If positive, then +1, is negative, then -1. So h of x is what? H of x is sine of this whole thing. This whole thing we can write it like this. I equals to, now it will become 0 to d, because this w0 x0 is also included now. So it will become I equals to 0 to d wi xi. Okay, the summation of wi xi from I equals to 0 to d, and we are taking sine of this whole thing. So now this is the hx, or our hypothesis, which will give us the credit approval system. So this thing we can write like this: w0 x0 plus w1 x1 plus w2 x2 up to wd xd. Okay, so this is a d-dimensional vector. So this thing will be written now as sine of this inside the sine function. This whole thing will become w transpose x. So is this w is the weight vector, okay, or we can say weight matrix. We are taking the transpose of this w matrix, and we are producting this with x. Okay, we are multiplying this matrix with x vector. Okay, so see, this w0 x0 w1 x1, this is a mathematical formula. Okay, if you are not good at mathematics just like me, then just remember this particular part. In this whole PLA thing, you do not have to remember any of this. Just remember this particular formula, and if you are good at mathematics, then you should already know this. But if you are not, just remember this. If there are values that like this form, w0 x0 w1 x1 w2 x2, like this form, we can write it like this: w transpose x. Okay, this t means transpose. We are making transpose of the w matrix, and we are multiplying it with x matrix or vector, whatever you can say. So now this whole thing, or this whole thing, becomes w transpose x, and it is inside the sine function, because this w transpose x is doing what? This w transpose x is giving us the whole value of this thing, and this sine is checking that if it is a positive value or negative value. So if it is positive, it is giving us +1. If it is negative, it is giving us -1. +1 means it is a good customer, so approve the loan. -1 means bad customer, deny the loan. Okay, so this data is suppose a linearly separable data. Okay, so then it will work fine, because this value, this weighted value, okay, but this weight matrix will give us a straight line which is going to divide or differentiate the customer data into two parts. Okay, suppose at first the line is like this. Okay, so now the data is differentiated into two parts, but you can see there are both plus and minus values in both sides. So our aim is to modify this line as such that the minus are at one side and the plus are on the other side. Okay, so this line we can modify it by which? By the weight values. Okay, so the value of the weight vector we are going to change such as that this line differentiates the minus and plus accurately. So now our aim will be to achieve this state where all the plus are on the other side and minus is on the other side. It can be on different sides also, but only one side there will be plus and the other side there will be minus. Okay, so it is applicable for linearly separable data. So now we are going to see the perceptron learning algorithm and how it works. Okay, so first this is the function we got from our previous part. Okay, that is h of x is sine of w transpose x. Okay, this is our function, remember this. Now what we do in our PLA algorithm or perceptron learning algorithm, first we get one misclassified point. Okay, now we want to find the correct values of the weight vector. So we want to modify the weight vector every time we find a misclassified point and make it correct. What do we mean by misclassified? That is, if a point is actually positive 1, that is +1, and our algorithm or our machine showing it as -1, then we need to modify our algorithm so that it becomes correct. Okay, so this is our function sine of w transpose x. So suppose for a particular point xn, the sine of w transpose xn does not match actually our actual value, that is yn. This is the actual data yn, and this is what our algorithm or our learning hypothesis, is producing. If these two does not match, then we need to change and update the weight vector. Okay, so what is the weight vector? W. So how we change it? We change it by this. W becomes w plus yn xn. Why we do this? I will be describing this to you soon. So we just update the weight vector by w plus yn xn, okay, by this method. So how many times we do this? We do this until we get satisfactory result. That is the basic algorithm or the PLA, which we are going to show you soon. But just first, for now, we are going to show you how this thing actually works. Okay, why we are doing this thing. So suppose there is a data y equals to plus 1. Okay, suppose where is y equals to plus 1. Suppose actual value of yn is plus 1. Okay, so our value is giving us what? Our value is giving us minus 1. That's why there is a mismatch. Okay, our function is giving minus 1. So we do what? We do w plus yn xn. So yn's value is plus 1. So it will become what? W plus xn. So if w plus yn xn and y value is plus 1, then it will become w plus x. So this is x vector and this is w vector. Okay, so if we do w plus x, the resultant will become what? The resultant will go through in between w and x. So it will be moving towards our x vector. Okay, so it will be moving towards our x vector. And let's see if y is minus 1. Okay, suppose y is minus 1 and here this is our w and this is our x value, already existing values. Okay, w and x. So now y is minus 1. So w plus yx will become what? It will become w minus x, because y is minus 1. So it will become w minus x. So if we want to do w minus x from here, then the resultant will go away from x. Okay, so the resultant w will shift to away from x. So this will be our resultant value. So why we are doing this thing? Let's see with an example first. Okay, suppose y's value is plus 1. Okay, y's value is plus 1 means the data actually is positive value. Okay, so suppose this is our data set. All the negative values are on the this side of the line. Okay, this is the separation line, and all the positive values are on the beneath. Okay, on beneath it. So only this plus value is our mismatch point. So y's value is equals to plus 1. This means the actual value should be plus, but it is showing, our hypothesis is showing it in the minus region. See, our hypothesis showing this particular point in the minus region, but it is plus because we know y's value is plus, so it should be on the plus region. So we need to do what? We need to rotate this line towards this side, so that this plus will become inside this. So see, now if we rotate this line towards this, then this plus is now in the plus side and minus is on the other side. See, so for y equals to plus 1, the rotation was doing on the this side, and now this plus is inside this. Okay, and for example y equals to minus 1, see, for here every negative value is on the this side, but this negative value is on the positive side. So y is minus 1 means our actual value should be negative, but our algorithm showing this negative in our positive side. Okay, so we need to rotate the line towards the positive side now. So we need to rotate this. So as we show you, for y equals to minus 1, it moves away from the x. So now it is rotating in this side, and now it is again on the, all the negatives are on the one side and positives are on the other side. So that's how this algorithm works. Every time we get a misclassified point, we rotate it and make that misclassified point correctly classified. So now let's check the algorithm of the PLA. First we randomly assign values for the weight vector. Then we do this. We repeat everything inside this loop, okay, until we get satisfactory result. So see, for we run a for loop from n equals to 1 to capital N and check if the yn value, that is our actual output value, is equal to the value we are getting from our hypothesis, that is sine of w transpose x. Okay, w transpose x is the hypothesis we are using. Sine of w transpose x is the hypothesis we are using. If this value is exactly equals to the actual value, that is yn, if these two are matching, then we do not do nothing. But if there is a mismatch, if this classification is done wrongly, then we need to modify our weight vector, and we do what? We add this with w and xn. So now this weight vector becomes w plus yn xn. Okay, so we repeat this until we getting satisfactory result, that is whatever your company suppose asking that 2% error is allowed, so or 5% error is allowed, that depends on you. So now every time you run this, it will be going to convert soon, because if the data is linearly separable, then after very few iterations we get satisfactory result. Okay,